Okay, hello everyone. I'm doing a electronics project here. Um, I was on the internet and I found a YouTube channel called Only Using Transistor Circuits. That's the name of the YouTube channel. And this person had a very interesting circuit on there. He called it the positive-negative edge triggering circuit using transistors. And of course, I enjoy working with transistors myself, and so I found that pretty interesting. So I was watching the channel, and he explained how his circuit worked. And this is my diagram of using switches here, but he had resistors connected with wires, jumper wires, to switch the inputs. And he did a nice job on explaining how the circuit works and everything. So if you're interested in how the circuit actually works, I suggest you go to the YouTube channel here, his channel, and watch his video on that. And then when you can come back to this and see what I added on to this. He demonstrated the circuit working here, and he showed how he can get a different output here with a positive input and a negative input, and he was showing how that was demonstrated by switching the wires back and forth manually. And I thought that there might be a way of being able to do that using a different kind of a circuit added on to that, that instead of manually switching wires back and forth, that you can actually have one input coming in and two switches. And so I came up with the added on circuitry here. This is his circuitry up here, and I just added this bit right here. I just added two transistors, two diodes, and a few jumper wires. And the way his originally worked is like this. Okay, so what I did was I added the two transistors here, two diodes. One transistor is an NPN transistor, the other one's a PNP. And I'll show that diagram, but let me just show how this works now. When I push this here button here, this would be the positive input, and when I push this down, the light will come on the leading edge of the positive trigger, just like his does. And then this switch here represents the negative input, and the light will come on only on the trailing edge of the negative input. So when I push the switch down, the light stays off. When I let the switch up, the light comes on the trailing edge of the negative pulse. So it's working just like his was working, only instead of switching the wires back and forth like he did, I'm just doing it with two separate switches and getting the same output, but also make it more convenient than having to switch wires back and forth. That's all this is for. This was just an add-on circuitry onto his to just make it more convenient for the inputs. And I suggest that if you want to learn how his circuit worked, go to his website, go to his YouTube channel, find how that works, and then see why I added this in here and to see how it works. Now I'll show you a schematic of what I added on here now. Okay, in order for his circuit to work, you have to have one of these bias resistors connected at all times. So if you wanted to use a negative edge detector, you would have to connect this top resistor, the supply resistor, and then you would have a push button or a switch on the negative input here, and that would give you the output that we were looking at. If you wanted a positive detector, then this would have to be closed here, so that there would have to be a continuous circuit going around this way, and this would have the open for a input switch. You have to have one of these connected at all times for that to work. Now, the reason that is because these two resistors here is what's necessary to discharge the capacitor. Without one of these being connected at all times, the capacitor has no way of discharging and for a new signal. Now, looking at how he was doing that, switching it back and forth, that's why I said I'd come up with a add-on circuitry that would make it possible to have two separate buttons with one input coming in, where those two separate buttons can be separated into electronic signals maybe. But anyway, this would not have to switch wiring around. And here's what I did. Okay, so what I do now is I relocated the 1K ohm resistors that he originally had here, and these 1K ohm resistors now become bias resistors, base bias resistors for two transistors. Now for the low side, I use a PNP transistor, and I connect its emitter. The collector connect directly to the low side, base bias resistor, and the emitter connected to the input of the rest of the circuitry. I did the same thing for the top here. To the power supply side, I use a NPN transistor and connected both emitters together, the PNP and the NPN. Now what happens is both of those transistors now are continuously on, setting up a voltage at this point here, roughly around half the supply voltage. So the capacitor is now charged to half the supply voltage. There's now an equilibrium going on here. The light is off on this circuitry now. Now what I did after that was to give an input now, and that's where I use the diodes. I'm running out of room on my board here. What I used was diodes that go directly into the base of both transistors. So what I have here is on this transistor here, I have a diode coming in this direction, and a diode coming out of this direction this way here, connected together to two separate buttons, one for a positive and the other negative input. These are two separate push buttons. Okay, now here's how it works. If we input a positive signal to here, that becomes positive. That there causes this diode to conduct current that was originally flowing into the base. Negative current flow into the base of the PNP transistor is now directed away from there, causing the PNP transistor to shut down, which allows the NPN transistor now to conduct. It rises more positive at this point here, above the half the supply voltage, and causes the capacitor to recharge up, causing a signal to go through and turn the light on. At the same time, by hitting a negative pulse to this, would then in turn take out the NPN transistor, causing the PNP transistor to conduct continuously, causing another signal to be directed to the base of this transistor, causing the light to turn on the trailing edge of the negative pulse, just as we originally had before. But what these two diodes do is they're just separating both bases of both transistors to keep them from interacting with each other, so that a signal that comes in will be directed to one base of each transistor. The negative signal would be directed to the NPN, and the positive signal would be directed to the PNP, and thereby causing these transistors to be turned off with respect to the signal input to them, so that the other transistor can cause a signal to be advanced through the capacitive resistant network here, that would then cause the transistor to respond accordingly. So that's the add-on circuitry that I added on to it. And this add-on circuitry was just, like I said, just to give the convenience of not having to switch the wiring back and forth as he was doing on his circuit demonstration. and I gave him a comment and asked him if it would be okay if I used his original circuit on my video here to show how I added this in, and he said it was okay. And so that's why I'm doing this video, to show that there can be an add-on circuit onto this here to make the circuit work differently with different inputs now, two button inputs now. So that's how that circuit was added onto that and how that works. And as I said, in order to understand the full function of how the circuit works, you need to go to his YouTube channel to find out how that works, and then you can understand why I put this add-on circuitry in there. Okay, thanks for watching. Bye.